Title: What did Neanderthals actually sound like? For most of modern history, scientists pictured Neanderthals as grunting brutes, big-boned, heavy-browed, incapable of real speech. Then in 1989, archaeologists digging in a cave in Israel pulled a small horseshoe-shaped bone out of the earth, and everything began to change. That bone, a hyoid, is the anchor point of the human voice, and the Neanderthal version was almost identical to ours. The question of what Neanderthals actually sounded like is no longer a cartoon question. It is one of the most contested and fascinating problems in human evolutionary biology. The Kebara cave in northern Israel has been a rich source of Neanderthal remains since excavations began in the 1980s. But the hyoid found there in 1989, from a specimen called Kebara 2 dating to roughly 60,000 years ago, was in a category of its own. The hyoid is a floating bone, not attached to any other bone directly, sitting at the base of the tongue and anchoring the muscles that control the larynx. It is essential for the production of complex speech. In most animals, the hyoid sits high in the throat, which limits the range of sounds they can produce. In modern humans, the larynx sits lower, creating a longer resonating chamber above it. And that chamber is what gives us the acoustic range to produce the wide variety of vowels and consonants that human language requires. The Kebara hyoid was the first and, for a long time, the only complete Neanderthal hyoid ever found. When scientists examined it, they found something striking. Its shape was nearly indistinguishable from a modern human hyoid. The curvature, the thickness, the attachment points for muscles, all of it matched. When a 2013 study published in PLOS 1 subjected the Kebara hyoid to micro-CT scanning and biomechanical analysis, the result confirmed what the shape suggested. The internal architecture, the distribution of bone density, the stress patterns under load behaved the same way a modern human hyoid behaves. That is relevant because the way a bone loads and distributes stress during use reflects the functional demands placed on it during life. The Neanderthal hyoid was being used the way a human hyoid is used. But the hyoid is not the only evidence. In 2007, a genetic study extracted DNA from Neanderthal remains and found that Neanderthals carried the same modern human variant of the FOX2 gene. FOX2 is the only gene identified so far that plays a direct and known role in language. Mutations in FOX2 in modern humans impair the fine motor control of the mouth and face, disrupting speech production. The Neanderthal version of FOX2 matched ours precisely, and since the modern human variant evolved in the common ancestor of Neanderthals and Homo sapiens, it was already present at least 400,000 years ago. More recently, work on the inner ear anatomy of Neanderthals added another piece. A 2021 study reconstructed the hearing capabilities of Neanderthals from the bony structures of their inner ear and found that their hearing bandwidth closely matched modern humans, specifically in the frequency range of 1 to 6 kHz, which is the range that contains most of the acoustic energy in human speech. The researchers argued that this overlap is not coincidental. Hearing evolves alongside communication. An inner ear tuned to the frequency range of speech is evidence that the communication system in use was operating in that range. So what did the voice itself sound like? A 2021 computational modeling study led by researchers at the University of Vienna and published in the journal PLOS Computational Biology attempted to answer this directly. They used CT scans of Neanderthal skulls to reconstruct the probable shape and length of the Neanderthal vocal tract, the pharynx, the oral cavity, the nasal passages, and then modeled the acoustic output computationally. Their findings were specific. Neanderthals could produce all 5 cardinal vowels, e, a, and u. They had the vocal anatomy to generate complex consonants and to modulate pitch and loudness. Their range of possible sounds largely overlapped with modern human speech sounds. But the overlap was not complete. The Neanderthal vocal tract was slightly shorter than a modern human's, and their skull base was angled differently, both factors that affect the resonance of the voice. The result, according to the modeling, would have been a voice that was somewhat higher in pitch than a typical modern human male voice, slightly flatter or more nasal in timbre, and with a narrower dynamic range. Some sounds that modern humans produce easily, certain vowel distinctions, certain consonant clusters, would have been more effortful or less distinct in Neanderthal speech. The pitch finding is counterintuitive given the popular image of Neanderthals as deep-voiced, hulking creatures, but it follows directly from anatomy. A longer vocal tract produces a lower fundamental frequency. Neanderthals were heavily built but not dramatically taller than modern humans, and their vocal tracts were not longer than ours. If anything, the differences in skull shape would have pushed their pitch slightly upward, not downward. What this does not tell us is whether Neanderthals had language in the full linguistic sense, a system with grammar, syntax, recursion, and symbolic reference. Anatomy constrains what sounds can be produced. It does not determine how those sounds are organized into meaning. The anatomical evidence shows that Neanderthals had the hardware for complex speech. Whether they had the software, the cognitive architecture for language, is a harder question and one the bones alone cannot answer. The behavioral evidence provides some indirect clues. Neanderthals buried their dead, sometimes with objects. They used pigments, including ochre and manganese dioxide, in ways that suggest symbolic or decorative intent. They made jewelry from eagle talons and shells. They controlled fire, planned hunts, and coordinated group behavior over extended time and space. None of these behaviors requires language in the modern sense, but they are the kinds of behaviors that in modern humans are tightly linked to language. The current consensus among researchers, not universal but dominant, is that Neanderthals had some form of spoken communication that was more complex than the vocalizations of other great apes, and that may have approached, even if it did not fully match, modern human language. They had the anatomy for it, they had the gene for it, they had the hearing for it, and they lived in social groups that would have benefited enormously from it. What they sounded like specifically remains a reconstruction rather than a recording, but the reconstruction has become much more detailed than anyone imagined. In the decades when Neanderthals were simply assumed to be pre-linguistic, the voice that came out of those heavy skulls was not a grunt. It was something closer to a human voice, slightly higher, slightly flatter, recognizably similar, speaking words we will never know, in a language that has left no record except in the shape of a small bone found in a cave in northern Israel.